Hi, my name is Yasin Zarwal. I will guide you in this lesson, which is a lesson from the CCNP routing and switching course. The difference between HSRP, VRRP, and GLBP, which will cover the following: router redundancy in multi-layer switching, the difference between the first hop redundancy protocols, and load balancing with HSRP. Router redundancy in multi-layer switching. Multi-layer switches can act as IP gateways for connected hosts by providing gateway addresses at VLAN SVI, switched virtual interface, and layer 3 physical interfaces. The switches can also participate in routing protocols just as traditional routers do. For high availability, multi-layer switches should offer a means of preventing one switch, which is a gateway, in case of failure from isolating an entire VLAN. This lesson discusses the difference between the following first hop redundancy protocols: hot standby router protocol HSRP, and VRRP, which is the abbreviation of virtual router redundancy protocol, and gateway load balancing protocol GLBP. This table will describe the difference between HSRP, VRRP, and GLBP. HSRP, which is a Cisco proprietary protocol, VRRP, which is a standard based, and GLBP, which is a Cisco proprietary. The router that's actively forwarding traffic of the subnet is called the active router, and in the VRRP is called master, and in GLBP is called AVG, which is the abbreviation of active virtual gateway. The router that is candidate to become the next active router in the HSRP is called the standby router, and in VRRP is called the backup router. In GLBP is called AVF, active virtual forwarder. For the HSRP, it is defined in IETF standard RFC 2281 if you want more details, and VRRP is described in RFC 3768. For the HSRP, we have in the configuration standby group. For the VRRP, we have VRRP group, and for GLBP, we have GLBP group. In HSRP, we have only one active router and one standby, and all the other are in the listening state. For the VRRP, we have one master and all the other in the backup state. And for the GLBP, we have only one AVG and all others are AVF. And all the routers are in active state. For the HSRP, there is no load balance. Also for VRRP, there is no load balance. And GLBP, we have load balancing. The default priority is 100 for the three HSRP, VRRP, and GLBP. HSRP election is based on a priority value, which is from 0 up to 255, that is configured on each router in the group. By default, the priority is 100. The router with the highest priority value becomes the active router for the group. If all router priorities are equal or set to the default value, the router with the highest IP address on the HSRP interface becomes the active router. The election is based on the high priority, and after that, high IP address in HSRP and also in VRRP and GLBP. For the multicast, here we have multicast group addresses to which hello or advertisement is sent. In HSRP is the IP address 224.0.0.2 in version 1 using UDP port 1985, and 224.0.0.102 in version 2. Please notice that version 2 in HSRP multicast supports IP version 6. For the VRRP, the multicast IP address is 224.0.0.18 using UDP port 112. For the GLBP, the multicast IP address is 224.0.0.102 using UDP port 3222. For the HSRP, we cannot use interface IP address as virtual IP address, but for the VRRP, we can use interface IP address as virtual IP address. For the GLBP, we cannot use IP address. We cannot use interface IP address as virtual IP address. For the HSRP authentication, HSRP can use authentication method to prevent unexpected devices from spoofing or participating in HSRP. All routers in the same standby group must have an identical authentication method and key. You can use either plain text or MD5 authentication. The same for VRRP and also GLBP. Default hello interval, which is 3 seconds for the HSRP. For the VRRP, we have default master and advertisement interval, which is 1 second. For the GLBP, we have default hello timer 3 seconds. For the HSRP, default hold time, which is the time after which we consider the active router to be down, which is 10 seconds for HSRP. For the VRRP, we have master down interval, and we have a formula, which is 3 times master advertisement interval plus the skew time, which equals 256 subtract VRRP priority. The amount is divided by the 256. For the GLBP, the default hold time is 10 seconds. Regarding the virtual router MAC address is of the form of 0000.0C07.ACXX in version 1. And for the version 2, we have 0000.0C9F.FXXX in version 2, where XX or XXX represents the HSRP group number. For the VRRP, virtual router MAC address is of the form 0000.5E00.01XX, where XX is a 2-digit hexadecimal VRRP group number. Virtual router MAC address is of the form in GLBP 0007.B4XX.XXYY. The 16-bit value denoted by the XX.XX represented 60 bits, followed by a 10-bit GLBP group number. The 8-bit YY value is the virtual forwarder number. Regarding the preempt option, is not enabled by default in HSRP, and it is enabled in VRRP by default. Preempt option is not enabled by default in GLBP. For the HSRP can track both object and interface status. For the VRRP cannot track interfaces but can track IP SLA object groups. For the GLBP can track both object and interface status. This comment can show the details. For the HSRP, we can use show standby. For the VRRP, we can use show VRRP. For the GLBP, we can use show GLBP. GLBP is supported only on Cisco 4500 series and 6500 series switches. The load sharing is done in one of 3 ways. Weighted load balancing. Traffic is balanced proportional to a configured width. Host dependent load sharing. A given host always use the same router. Round-robin load balancing, each router MAC is used to respond to ARP requests in turn. Load balancing with HSRP. Consider a network in which HSRP is used on two distribution switches to provide a redundant gateway address for access layer users. Only one of the two becomes the active HSRP router. The other remains in standby. All the users send their traffic to the active router over the uplink to the active router. The standby router and its uplink essentially sit idle until a router failure occurs. Load balancing traffic across two uplinks to two HSRP routers with a single HSRP group is not possible. Then how is it possible to load balance with HSRP? The trick is to use two HSRP groups. One group assigns an active router to one switch. The other group assigns another active router to the other switch. In this way, two different virtual router or gateway addresses can be used simultaneously. The rest of the trick is to make each switch function as the standby router for its partner's HSRP group. In other words, each router is active for one group and standby for the other group. The clients or end users also must have their default gateway addresses configured as one of the two virtual HSRP group addresses. The other approach or trick is, which is the following. We can have different HSRP group for different VLANs, and that gave us some load balancing. You can assign interface data VLAN to HSRP group 1 and assign interface voice VLAN to HSRP group 2. Then we can have one router to become active router to HSRP group 1 and the other router to become active router to HSRP group 2. Which means each router is active for one group and standby for the other group. My recommendation, if you configure HSRP groups on several VLAN interfaces, it can be handy to make the group number the same as the VLAN number. Thank you very much for your viewing.